This is my second lab on lines of charge. The purpose of this lab is to expand on Lab 1 and provide a better estimate for the amount of charge on one piece of tape. I found that the new model gives a bigger charge result than the simplified first model. We used the same experimental data from Lab 1 where we found the distance at which two charged tapes repel, but in our code we represent the piece of tape as a line of point charges. For the purpose of this experiment, we must assume that each piece of tape has the same charge and the charge is distributed evenly along the tape. The fundamental principles involved include the momentum principle and Newton's second law, which we use to show that when forces are in equilibrium, meaning the momentum is not changing, the net force on the object is zero. We use calculus to explain that the model will be more accurate as more point charges are introduced as a part of the tape because the final result is the sum of all the smaller sections. We also use the interaction between the electric force and field in order to find the value of the charge. F is equal to the electric force times the charge. A recap from Lab 1 shows the setup that we used in this lab, shown to the right, in which two pieces of tape were used to levitate each other. The tapes were observed to be attracted to neutral objects, repel each other, attracted to negatively charged pen, and have a positive charge. We also calculated an electron deficiency of 6.787 times 10 to the 10 electrons on the piece of tape using the charge calculated in the first lab. For this lab, the measurements used include the length of the tape being 0.205 meters, the mass of the tape being 2.05 times 10 to the negative 4 kilograms, the levitation distance between the two tapes being 0.023 meters, and the magnitude of the gravitational force being 2 times 10 to the negative 3 newtons. The electric force was found by being the opposite of the gravitational force, so the magnitude is the same, 2 times 10 to the negative 3 newtons. For this lab, we updated the coding to represent the pieces of tape as a line of charges instead of being concentrated as one point charge. I started the code by downloading the starter code available on Canvas, and then I used my charge calculated in the first lab to create the code. Once I had finished the code, I used the guess and check method to find the charge Q, which is shown here on the left, being 1.18789 times 10 to the negative 8 coulombs. I used my electric field function that I created in Lab 0, which is also shown in the left picture. In the picture to the right, the blocks of code highlighted in the black box represent the lines which I changed from the starter code. Lines 55 and 59 represent the electric field scale and the electric force scale, which I found. These two numbers are the result of the guess and check of me plugging in numbers and seeing which numbers were able to show the picture representing all of the arrows. In line 74, I updated the electric force on one of the charged pieces using the electric field calculated on one of the charged pieces 3 lines above, multiplying it by the charge on one of the small pieces in the tape. In line 78, I was able to update the axis of the electric field arrow by multiplying it by the electric field scale, which I calculated in line 55. On this page, you can see the picture to my right, which shows that the electric force and the gravitational force are equal, and the green arrows represent the electric field at each of those charged particles, which add up to equal the white arrow, which points up as the electric force, and the yellow arrow points down as the gravitational force. The code to the left represents how I multiplied the axis of each arrow to be the calculated electric field and electric force and gravitational force multiplied by the respective scale vectors. Using my current model, I have calculated a charge of 1.18789 times 10 to the negative 8 coulombs per piece of tape. This is similar to the 1.086 times 10 to the negative 8 coulomb charge calculated in Lab 1, but it is slightly bigger and it's calculated using a more accurate model. The charge is bigger because in this model it is spread out over a distance, and thus farther from the observation location, whereas in Lab 1 all of the charge is concentrated in one location as point charges. This new model, we assumed that each U-tape had the same amount of charge as the other, which we also assumed in Lab 1. The difference here being that we calculated the amount of charge by using a model representing a line of charges, which is more accurate, as I explained above.